Okay, let's see. 2.11, solving simple equations. Now, this section is about not just solving simple equations, but solving them from a word problem. In other words, they give you a word problem. This is a kind of like a process of how to set up an algebraic equation to be solved. Okay, I know that in the beginning here, these are going to be really simple and you can do them in your head, but it's actually how to go from, something that you can do to your head and make it into an algebraic equation and then solving it that way. Because as we all know, application problems do get harder and harder. Okay. And this is actually the ultimate goal. I usually don't go over these first couple pages. Um, but what you have to do is actually make a model of the simple equation and then pretty much just solve it. Okay. So we're going to go over it. And they did an example here. Um, Again, a very simple one-step equation. Eli says that he needs only $225 more in his account to reach the 1875 necessary for a down payment on a car. And like I said, most of us would do it this way. Hey, he only needs $225 more. He needs a total of 1875. So we would just, in our heads, or maybe in a calculator, just take the 1875 and subtract the $225 to figure out what he actually has in his account now. But like I said, these get more and more difficult. So they start out with these simple equations to go ahead and make an algebraic equation. So in other words, that means we have to throw a variable into it. Okay. The first thing you want to do in this process, define your variables. Okay. If you don't define a variable, then you kind of lose track of what you're actually doing with the word problem. So what they did was they're going to let B equal the current account balance. Remember, that's what we're trying to find. Okay. We don't know what it is until we actually subtract the 225 from it. So if he has the 225 in addition to his current balance, so this would be equal to B, his current balance, because we defined it here. So the current balance plus the 225, that's going to equal the 1875. And then to actually figure out uh, what that balance is, you just solve for B. Okay, so they use like this looks like a you know 2x2 box here of how to solve word problems. So we'll try to go through it. I know we could probably eventually skip this one and go straight to writing the algebraic equation. You actually should by now, because in Algebra 2, you did quite a bit. All right, so let's do an example problem here. It says, you watch a show in which people compete against each other to lose weight. The trainer exclaims, down 7 pounds in 1 week. On a screen behind the contestant is his current weight of 168. What is his weight last week? Well, again, this would be pretty easy for us to do in our head. He's down 7 pounds to 168. So right now, he's 168 pounds. You would just add the 7 pounds. This would be last week's weight because he lost the 7 pounds. Okay. It says which operation was used here. We added addition. If we were to solve the equation, we would use subtraction. Okay. Write an algebraic equation. First step, define the variable. And I'm going to use x because everybody's used to x. So I'm going to let x and we figured out what last week's weight was. So I'm going to let X equal last week's weight. Okay. So the equation is, well, that's what we want to know. We want to know what last week's weight was. So we're going to equal that X. Okay, so he weighs 168 now. He down 7 pounds in a week, so we're going to add that 7 pounds back in there. And that is our algebraic equation. And again, I know this is really simple at this time, but um, they just want you to get in, get used to the idea. Hey, this is numerical, and this is algebraic because we set it equal to x. And of course, if you solve the equation, we get 175 equals x. And we want to make sure that we check your work, and we know it is because, again, this is a very, very simple equation. Does 168 plus 7 equal 175? And of course it does. If you don't believe me, put it in the calculator. So, very simple problem that you can probably do in your head. And we made it as complicated as we can, as we usually do in mathematics, by making it an algebraic expression or equation, sorry, because of the equal sign, and checking our answer. Again, very simple problem so that you know more terminology than anything. It's going to get a little more difficult. Um, this box here tells us they've got these are like word phrases, English word phrases, and they're showing you what they mean. A number that is subtracted from x. Please be careful. It's not, they're using 5. So it's not 5 minus x. That's wrong. Okay. It's x, a number is subtracted from x. Okay. So we got x minus 5. 5 is the number being subtracted from x. Don't do 5 minus x. A multiplied by x, obviously it's straightforward, multiplying 5 times x. And x is divided by a number, which means x goes in the numerator, 5 in the denominator. All right, just some English phrases that you'll see in word problems. These are the meanings for them. Okay, your email account states that 3.36 gigabytes or 21% of the storage space has been used. How much total storage is allotted to your email accounts? And so this one's not so straightforward. So right away you notice that, hey, this is getting a little more difficult. But if you look at it, we could still, do this probably pretty simple in a calculator. We have 3.36 of gigabytes. It's 21% of the storage. So we're going to divide it not by 21%, but by 0.21. Okay. And if we did that, we get, put it in our calculators, 16. So 16 is actually, this is the total amount of storage, right? Okay, so if we were to write an algebraic expression, this would be our unknown. So we're going to let x equal the total amount of storage. Because that's what they asked us, right? How much is the total storage? kind of a hint. Okay, your variable most of the time, 90% of the time, is what they're asking you. All right, so we're going to write our algebraic equation. So we're going to take 3.36 divided by 0.21, and that's going to equal our x. And back at the beginning, they said something about an inverse or something. This is one of those inverse things. Okay. So what you would do to solve this was you would multiply one side by 0.21 to get rid of the 2 you would have 3.36 equals 0.21 of x. Then you would divide both sides by 0.21. And you would get your 16. That's what they meant by the whole inverse thing. Very confusing. Just take your 3.36 and divide it by 0.21. That's how we got to 16. Check your work. And of course, if you do put that in the calculator, it does come out to 16. Again, very easy problems that they're trying to make you understand how to take little bits of the English phrases and put them in a word problem. All right, number 4. You're reading the newspaper and see home value assessments. You guys will love this eventually in your lives for property taxes. Your house is listed at 42,340. Assessments are 1/3 of the true value of the home. What is your home actually worth? Okay, so your house is listed. You're reading this one, and your house is listed. So I want to make sure here. So we want to make sure that 1/3, I'm just going to write this out, 1/3 of our house equals 42, 340. Okay, so if I take that 1/3, add another 1/3, add another 1/3, I get my whole, this is my numerical, this is how I'm thinking about solving this in my head. So if I add all that up, I get the full value of my house, right? 100%, or 1/1, or 3/3, or whatever you want to call it. So if I take 42, 340 plus 42, another third, plus another third, I'm going to get the full value of my house. So I'm using addition. And 42, 340, 42, 340. Let's see if I can, I better use a calculator. Batteries, I can move. So 42, 340. And instead of doing it 3 times, I'm just going to multiply by 3. So either way, you could use addition or multiplication. My house is actually worth $127,020. Okay. Now, this is what we didn't know. So this is a true value, I think. So actually worth, right? Actually worth. So that's our variable. We're going to let x equal the actual worth. Okay, so 1/3 That's my actual worth. So 1/3 uh, 1/3 of my x equals 42,340. Right? 1/3 of my actual value equals 42,340. And we do that whole inverse thing again, multiply both sides by 3. So my x is going to equal $127,020. And to check that, oh, I'm sorry, I had my paper scooted. 1/3 x, I just took this equation and solved it. Multiplied both sides by the denominator 3 to get x by itself, $127,020. To check it, I would take my $127,020 and multiply it by 1/3 or 0.33 repeating, and I should get my 42 times 0.33. And this was rounded. If I use the actual fraction, 127,020 times 1 divided by 3, I should get my 42,340. Okay. So actually, what we did was we added it 3 times or more. Specifically, I think it'd be easier if we multiplied it. Okay. It's just equivalent by multiplying by the reciprocal, 3/1. I'm not so worried about that. Okay, let's look at example 2 here. Only 2/3 of the class was present on Friday. If 16 if 16 or yeah, 16 students were present, how many students are in the class? Well, to solve this, you would say, well, 2/3 of the class is 16, so 1/3 of the class would be 8. And all you have to do is, we know that we know that 2/3 is 16, so we know this has to be cut in half because it's 2 of them, 2 out of 3. That's why we know that 1/3 is 8 students. That's how they do it without a calculator. Okay, so we know that 2/3 of the class plus 1/3 of the class equals 1. So 2/3, 16, we know that the 1/3 is 8, so 16 plus 8 equals 24. This is how the whole fraction thing works. Remember back in 4th grade, you guys use pi and little pieces fit in there for thirds. We know that 2 of the thirds equals 16, so that means each third must be 8. All right, write an equation. We're going to let the n equal the number of students in the class. Remember, that's what they asked us. How many students are in the class? So they let n, I should use my pink one because that's what I've been using. Let n, instead of x, they're using n. Since 2/3 of is n, is 16, we get the equation 2/3 of n equals 16. And of course, solving the equation, you multiply by the reciprocal, or in other words, I like to think of it as multiplying by the reciprocal gives you the answer of 24. And if you replace n with 24, 2/3 of 24 obviously equals 16. So let's try this in the practice problem. Uh, Throughout your section, you have solved one-step linear equations, which are polynomial equations, of course. One-step equations can also contain a polynomial degree, such as x cubed equals 64. Whenever you choose to use algebra to solve a problem, you need to determine the operation done to the variable. Doing so will determine the inverse operation, what we call is undoing. Um, Doing so, we determine the inverse performed on both sides to isolate the variable. Homeowner has enough patio pavers to make a 200 square foot patio. He wants the patio to be square. What will the dimensions of patio be if he wants to use all the pavers? State your answer in feet and inches, such as 5 and 6. Okay, now with geometric shapes, uh, you can go ahead and use this process with the whole square, 4 squares and stuff. But I've taught my students for their entire mathematical careers in high school, in grade school. They were taught, well, hey, look, use the in this case it's area, um, square foot, because square foot, that's area. Use the formula for area. There is absolutely no reason you should change now in your senior year all of a sudden. So the formula for area of a square is side times side, or the area of a square is going to equal side squared. Okay, so our area we know to be 200 square feet has to equal, I'm going to use x for s, x squared. So we got to solve for x. So how do I get rid of a square root? A squared power. You square root both sides. So I get x equals, now square root of 200, put in my calculator, square root of 200, I get 14.14. So each side is 200 square foot. So this is 0.14 of a foot. So remember, they want it in feet. So I got 14 feet. Each side is 14 feet. And we need to find out what 0.14 of a foot is. We know that there's 12 inches in a foot. I got to multiply that by 0.14, and it gives me, try and make this a math, enter, 42/25 of an inch. Yeah, I'm just going to leave it as 14.14 feet. Yeah. We're not going to have feet and inches. Okay, I'm making an executive decision. Student feet. After building the patio, the homeowner is planning to build a cube-shaped bed. Now, cube is volume, okay? Cubic is volume. So the volume for a cube is x cubed. What is its dimensions in feet? And we're not doing inches, in feet. Okay, so the volume, 5 cubic yards. So we know that it's 5, substitute in 5 for volume equals our x cubed. We're going to take the cube root of both sides. Cube root. So the cube root, and I believe is, I forgot where it is in our calculators because I never use cube root. So I'm just going to take 5 raised to the 1/3. There is a cube key somewhere in your calculator. I just don't know where it's at. Is 1.71 yards. So x is going to equal 1.71. Don't forget we're in yards. Yards. They want it in feet. There's 3 feet to every yard. So I'm going to multiply it by 3 times 3, 5.13 feet. So each dimension in this cube so it's 5 feet wide, or I'm sorry, 5.13 feet length, width, and height because it's a cube. And that's it. That's how you make algebraic equations if from word problem. If you're doing geometric shapes, you know, use the formula method. Okay, it's even helpful if you make a picture square. I should have made a picture dealing with square where every side is an x. I should have made this cube where every side is an x. Okay. If you're using geometrics, use the formulas. And that's it for 2.1.